the BFF versus GraphQL, critical perspective indeed. But before we dive in, I would like to present myself a bit. My name is Mihaela Ghidersa, and I'm a software developer at Centric Romania. And besides my already presented deep interest in software and technology, generally, I also like to prepare presentations and trainings for amazing events like this one. So thank you to the organizers for the invitation. I'm honored to be part of such an amazing lineup of speakers. When I'm not speaking or coding whatsoever, I like to dance, sing, read, travel, you know, just your typical developer. Today I want to invite you to join me in a talk about a subject that's been very painful for me, at least in the last 1 year, one year and a half, and I'm still searching for the best approach. As you already noticed on the agenda, I want to discuss concepts and approaches. Most of them are from my experience or from projects that I had the luck to be near and learn from, so not making all the mistakes by myself. But I'm extremely interested in your experiences also. I really think that we can add up to this presentation and do a two-way knowledge sharing. So let's just get it on. When you're working in a distributed team, and by distributed I mean front-end and back-end developers, yeah, two teams that are different, it's pretty hard to avoid the frustration at some point, especially when there are, let's say, some complex functionalities at some point. And it's pretty hard to not get to the point where front-end developers think that why can't back-end just give us the payload that we need, and what are they doing anyway? What is their job? Not to serve what we need in order to display on the front-end. On the other side, we have the back-end developers that just think that, you guys, why are you complaining all the time? You're just moving pixels around and displaying the data that we are giving you. Just work, do some work with what we are giving you. This is in very stressful situations now, because usually we are collaborating and team players and everything. But before digging in, I have to tell you that before being a more front-end oriented developer, I used to do full stack. So I will take the liberty to talk about both sides today. Usually working in a distributed team can be a bit frustrating, as we already said, unless you're creating both the front end and back end, which is a lucky situation. Because there are a lot of discussions about the data used, performance, inconsistencies that appear. We like it or not, this is the situation, we have to deal somehow with it. If we're going a bit in time, the feeling was always that the backend developers have always done the more smart and serious programming. They were thinking about meaningful issues such as testability, maintainability, the state management, the design of APIs, while the front-end colleagues played with pixels and just made things look pretty. The reality, though, is a bit different, because JavaScript absolutely exploded in the last years. And a lot of the responsibility went from the backend part to the front end. If in the beginning we had to deal with very specific pillars, such as some HTML, some CSS, JavaScript, some preprocessor language maybe, now everything got way more complex. Now we are thinking about the same problems in the front end as we do in the back end. The separation is no longer valid, if ever existed one. The issues that we talked before, as perceived backend matters, are now the daily debate and actually work of front-end developers or client-side developers, whatever you want to call it. So today we are talking about the application and the development team, but specifically we talk about the workflow and the responsibilities in these distributed teams. And let's go just from the beginning. As a result of what I've talked before, when we talk about data that we receive from the server, the question that arises is, are clients managing too much? And if this answer is yes, well, the front-end developers are the ones that suffer from this. Front-end developers that will become frustrated for not being able to manage the code base anymore. Also, the need for refactoring appears way too often in order to gain some control back. So doing refactoring at 6 months or so is not fun at all. This also brings serious complication on the performance side. And you know who isn't happy about the performance issues? The users. And we are users also, and we know exactly how this feels. But aside from users are the clients, and most probably the project manager won't be happy about it. So yeah. And I want to start from the beginning, as I was saying, the place where the chaos really appeared, with the front-end developers saying, I need some additional data in the interface. I need to access a specific payload, something like this. And the backend developers were like, yeah, and just use what we are giving you. But jokes aside, there are two most used ironies, two alternatives. And it's ironic because we know them since forever and still having difficulties about how to handle. So we have the opportunity of just creating a new endpoint and using it, or add more data to the endpoint that we are already calling. So this seems like a good idea, nothing harmful. We are just creating a new endpoint and you are using it. And now our application will make 2 calls over the network instead of 1 for a certain action. Nothing bad in this. But what happens when this is done in a regular basis? If we add more 3 or 4 times of repeating this scenario, our application will end up with anything but something called performance. It will end up with something called chattiness. And this kind of mindset usually ends up with a lot of complex business logic in the front end and some adapter operations that usually shouldn't be in the client side. I would know because I've been there, tried to deal with that, maybe cried a bit inside at some point. But beside this complexity on the front end code-based, chattiness also brings a lot of network latency. Going to the other one, adding more data to the endpoint that we are already calling. So let's just say that you just talk with the backend team and they are providing you with the data that you need. And this is not a bad thing. But again, if we are doing this again and again and again, we will end up with something that we call fat payloads. You've probably seen this before. They are gigantic JSONs that we are trying just to go through in order to find the data that we need. And if you are very unlucky, you might work with an XML. So this is not funny when you have a very, very fat payload. Fat payloads are probably a better option than chattiness in an application, but it's not something really that I would like to come down to and have to choose from. So is there a way that we can go and resolve the situation? Well, we can talk about approaches that we had all over the time that they've been tested and see exactly how they've worked in order to find answer for the future. We've worked with endpoint APIs for so long and they've worked great, actually, when it comes to provide data to the client. But when it comes to specific use cases, sometimes this is not a very happy situation. While development in the client area went crazy in the latest years, as we were talking, the server has to fulfill more complicated scenarios. So this is how we end up with APIs that have to answer too many cases. For web application taken in different kinds of browsers, or more than that, to mobile use cases, which is even a more soft side to the application. So this sort of APIs are called these one-size-fits-all APIs. And they are often compared, or they are just named REST. And this way we just end up hating REST or saying that, okay, REST is not okay. But this is not REST. It's not about REST. It's about the architecture and the approach that we are using when we are designing the APIs. So it's very recommended, it's very good to actually understand the tool that we are using in the context of our application. Then we might say, okay, we are not working with the monolith anymore. I'm just going to switch to a microservices architecture and let go of it, the monolith, yeah, and everything that comes with the complexity in that side. And of course, in this part also, time showed us that there are a lot of benefits in this area, But there is one specific thing that, although it might not seem that important, might bring a lot of trouble to the front-end developers, because usually when we think about the architecture, at least from my experience and what I have encountered through the years, is that we are focusing a lot of the architecture of the server side, yeah, in order to be very, very specific and very well thought in order to grow and to avoid technical depth maybe later. But how about the front-end part? How about the client? How about the data that the client is using while growing? Because in the end, that is the part that the user is meeting. And we have to be very careful about how performance is handled in this communication. And I'm thinking, by doing so, by having these services that bring us data that we have to actually aggregate in the client, so bring some business logic in the client, does that make the client responsible for the complexity? In other words, isn't this invalidating one of the important attributes of great APIs, which is observing complexity? I guess at this moment, it just feels natural to feel a bit stuck, because it might seem that we have a lot of options, but none of them is good, or something like that, or is bringing issues. We are somehow driven by some constraints that we hardly have control over. We can't predict everything from the beginning when we are first thinking about our application development. But how about we change a bit the perspective and look at the advantages that as front-end developers, we are the closest to the users, right? And we are the ones that provide the interface that the user works with. So why don't we just gain a bit more responsibility in our work? Would it sound that crazy for front-end developers to build some own servers? How about deleting or erasing this, this limitation that we have between front-end and back-end and try to find a middle ground? So we are going to start by talking with this backend-for-frontend pattern and what it's all about and how actually it can help us in this sort of situations. The first most popular production approach of this kind was presented at Netflix, because they announced in somewhere in 2012 that made a complete API redesign. And they were saying something like, they found themselves to be very limited by the REST APIs, although they are also using a one-size-fits-all approach. And they wanted to just do something that can be more custom in order to API design. So they started from this reality that they had a lot of devices that they had to serve. And that also meant a lot of fallbacks for every and each single one of them. And with these fallbacks also appeared a lot of specific use cases. So the most effective solution seemed creating a new layer, a middle layer, between the client and the server, where the client can actually create some code, some client code specific, modeled to the needs of the client. So somehow let's say the power, it was in the client side, so in the developer, the client developers. This might sound something like writing many custom endpoints. And it's very important to note that this architecture makes operations so much more manageable also to the client. So this to the server. So this way the server, it's more about gathering the content, while this adapter layer gives the shape of the data and just makes it in a client specific way in order to just have control over what we are serving in the end in the interface. So what does this mean? That the clients, the front-end developers had control in creating their all own client adapters on the server. So they began to be accountable for this. A very similar situation is at SoundCloud. Again, they had a lot of issues with the way their APIs were created. So they ended up having pretty much the same problem as in Netflix, related to requesting every time the data in a specific way. So this issue somehow made them rewrite a lot of parts of the application, and you know, all the flows of rewriting and estimating and trying to find time to do it, and so on and so forth. So the solution they found is the same. We are talking about the Backend-For-Frontend approach. And basically, in this way, the developers had the freedom to optimize specific use cases without needing to worry about other use cases than the ones that they are dealing with on a certain client. So it's easy to say that this is a best friend forever situation, right? Well, we'll see. But it seems, though, that this pattern really helps creating a friendship, I don't know if forever, but a good friendship between the front end and the back end. Because the goal of this is to decouple the front-end application from the back-end architecture. The BFF is all about building a layer that meets the exact needs of a specific client. And one of the advantages in this pattern is the reusability of the code, because all the clients have the possibility to fetch data from for their specific BFF server. They can create a cache, making the processing less complex and the client less chatty, which it was an issue that we've already discussed. So let's go a bit deeper in the problem and see a very traditional way an application it might be built when we just are calling backends for specific clients that we are having in what is happening. The issue about this is the number of requests that, since the services are created in a very generic way, and the funny fact, last week I heard a new name for the generic services, which is universal services. So this just sounds great. So they are created in a very generic way, and it's very hard for them to fit more specific needs in order to, if we just make this very simple comparison between web and mobile, which we know that the needs of, in terms of payload and the performance, it's a difference, a very big difference between their needs. So in order to minimize the number of requests and give the proper payload, it means that sometimes the backend will do some UI related processing that needs to actually give to the client what it needs. Or if they are not doing this, the client will have to bring some business logic on the front end. So one way or another, we just end up thinking about in which camp we throw the fireball, which is not cool. But if we change a bit of perspective and look at the BFF approach, we will see that the biggest difference between the BFF and the traditional backend architecture is that in the BFF approach, the client no longer calls the generic backend, or how this is actually happening is by doing the processing in that specific area. Yeah, so we are talking about the mobile BFF or the web BFF. In this specific image, we have it expressed like this, but we can also have more web applications, more different web applications that are actually consuming the same services. One way or another, each client will have its own BFF specific service. And this way we are doing some processing at the BFF level for the UI logic. And of course, this results in fewer mutual calls between the different services, what fits in the other case. So as we can see, the client is being satisfied on its specific requirement. And this thing wouldn't be possible, or at least not easily done, for a specific server that returns specific data on one API. Because, well, what for one client might seem like the perfect set of data, for another one might seem even not enough or too much. And we don't want to get into the situation where we are giving too much. So we are going with a lot of data that is not needed in one single call. If we move the discussion in the mobile side of the picture, the issue even becomes to grow bigger, because using the same payload for a web client as we do for a mobile client, it's a very big trade-off in terms of latency, especially since we can control the power of the network of our application. I don't know where it's going to be working on, and we can just think about ourselves, how we are reacting when I'm just in a slow network. I'm never saying, oh my God, the network, it's so bad. I'm thinking, okay, this application is so slow. Oh my God, what developer built this? So this is how our users are reacting to. They are thinking about the fact that the application is slow, not the network. So we have to take into consideration also this, and limit as much as possible the calls that we are using. So this way, creating a specific BFF service will result in all the processing being created at the BFF level, and then just giving to the mobile or the web specifically what is needed. And I'm going to stop a bit. I just remember a question that someone asked a couple of days ago, and he was saying something like, if we are moving the place where we are doing the calls from, basically, what is the change? Because you are actually working with the same services. So if the services are slow, what is the difference? Well, yes, he was right, but we have to take into consideration that the server-to-server calls are so much more lower in latency, and that gives us a huge improvement in performance if we is to compare it with the direct network calls that we are making from the browser. Add up to this also the payload that is significantly smaller and specific, and you will understand where the difference actually is. So if, let's just draw an intermediate conclusion. What's the deal with this BFF? It's providing all the data that the client needs. This seems very clear that we are just doing the processing in there and sending it to the client. Less response time, already discussed about it, but also this depends upon the technology and the approach that we are using. But as we already discussed, there are some significant improvements in this area, so it's coming with a plus. It should be resilient. We have to take into consideration performing some load testing on it, and also if we still have some services in the backend that are very, very slow and are taking maybe too much, well, maybe we should just consider returning a partial result in order to actually keep working with them. So there are some approaches that we can do in this area, but it depends from case to case. And the use of caching that, especially when it comes to failures from the services, we can do a very good use. And also we can identify the areas that don't need, or they don't have updates on the data so often, that we can also do some caching in there. So if it's to go from a higher level perspective, both pattern search actually are working towards the same goal. So if I'm thinking about an API gateway and about the BFF, what exactly is the difference? Because they are both decoupling the services from the specific clients that use them. So why should I use a BFF and not an API gateway if I have it already? Let's look a bit also into this. In this specific case, the API gateway does not distinguish between client types. This is a situation that I encountered, and it brings issues in matters of performance, in the payload, trying to work with a lot of data that is not really useful. So you might need just 3 properties from a list of, I don't know, 20. So you just work with a lot of data that is not needed. So in this case, the API gateway, it's actually, besides a single point of entry for all the clients, also not really doing something in terms of processing of data, or performance improvements. In this case, the API gateway determines which client it comes from based on different APIs. And it makes some processing by handling them separately, because it's returning the requested resource, having into consideration some routing approach. If you're interested more, I haven't used this approach, so I can't really give an insight on it, but if you're curious, the pattern is named the gateway routing pattern, so maybe you can suit the situation in your application if none of the others are doing so, but you might want to take a look on this. And the last one, it's actually the most approachable when it comes to comparing it to a BFF, because the representation is very similar. But also into this, I want to make a specification that you are, even though it's pretty similar, you are first depending on something that is external of your application. Well, this if you're not building it yourself or something. And the second, you might depend on a single point of failure that might be a bit inflexible when it comes to maintainability. We had some situation when this just failed and the application failed also, and that was it. We couldn't use it just because it was external and we had no power over it. But the question now it's, okay, since they are so close to each other, the differences are not extremely big. How do I decide which one to use? We can ask some questions like, how different the data that my clients need it is. It's a very different payload. It's a matter of some properties and it's not something significant. Also, I can ask myself, okay, my clients are all using REST, or maybe it's any of them that is using GraphQL. So do I have to be able to engage in supporting different communication protocols, or I'm just fine with only one of them? On another side, I have to think about, okay, do I need to do some aggregation if I'm using the API gateway? And if I'm using it, does it allow me the API gateway that I'm using? Because there are some that are not actually supporting this functionality. And if I'm still thinking about an API gateway, okay, but if it's not supporting this functionality, do I have the resources to actually build it myself? I have to think also in terms of resources, time, people, knowledge, and so on. When it comes to, let's say, cross-cutting concerns, yeah, I'm thinking about maybe authentication, data aggregation, all sort of operations that are pretty important to the application's health. Can I just, are they overlapping? Can I just overlap something in those API gateways if I'm using several? And if so, can this overlapping actually be handled at the configuration level of the framework that I'm using, or do I have to do something extra? So this depends again on very much in the situations that what you're having. But I want to make a statement that everything that we are discussing, all the approaches that we are discussing today, have a cost if they are used in the wrong context and in the wrong way. So even though I'm just using a tool that worked perfectly fine for another team, it doesn't mean that it will work for me. And of course, that the BFF is coming with some specific things to be aware of and be careful of. Duplication over use, of course, that if I'm building several BFS for several clients, I might end up at some point with some duplication somewhere. Of course, this is not a bad thing, because in the speed of delivering, yeah, we might end up with this. But if we identify this duplication in many places, we can consider the opportunity to just creating one or more shared libraries, depending on the situation, and get certain functionalities developed only once. So this is not really a problem. Another thing to be aware of and be careful is that since we have more services and components, the way we are doing actual since we have more services and components, we actually increase also the number of deployable units. So we have to be careful on how we choose our DevOps team and how are they handling this. So it's a matter of a lot of attention on the monitoring part, some automation, yeah, in order to not do a lot of the processes manually, because human error is a reality. So we have to be very careful about that also. And yes, take extreme ownership and inform ourselves on a daily basis about the trends and how exactly can we improve that area that we encounter to be a bit tricky when it comes to deploy it. So we discussed about the BFF and that it can help us in situations where we have to just handle one specific case or more similar specific cases or more clients or whatsoever. And while this approach gives us a lot of modularity, we need to be aware that there are still some points that need special attention in the idea that this contract between the client side and the server side is fixed. So in order to loosen up this interaction and dependencies, a cleaner way to serve different clients would be to call GraphQL to the rescue. So we are talking about GraphQL. I'm not going to go very much into implementation details, just giving a bit of overview. So GraphQL is a specification. They are stating very clear that it's not a library, not a product, and not a database. It started at Facebook. They tried to go from this approach of thinking in matters of tables and the keys and constraints like this to thinking about the data in terms of graphs. And this is exactly how they ended up with the GraphQL approach and the name also. And they also had this thing that, okay, we have to write a lot of code on both the server in order to prepare the data and also on the client part to parse this. So this is how they end up to creating and using GraphQL as an independent and then also being used by other entities and also now being available to us. So long story short, GraphQL provides a declarative way, as they say it in the documentation, for the UIs to interact with some specific data that they need. So we have again this matter of specific data. This data is shaped by some resolvers and the UI just fetches what is needed from there. When we talk about GraphQL, we talk about the query language and the schema language. And on one side, the query language, it's very cool because it allows us to fetch just the data that we need in a friendly and very efficient way. And coming to complete this context is also the schema language, where we can define our queries, operation, mutations, whatever we have displayed from the server that we can access and use. So with GraphQL, we are saying that we are using queries to get exactly the data that we need in one request. Other than this, maybe if you're curious or if you haven't used yet in matters of implementation and how the queries are built and things like this, I kindly invite you to go on the documentation they have on the site to see exactly how it's working, maybe do a proof of concept on it if you haven't had the chance for now. Because I would really like to go beyond the capabilities at this implementation level. And I would like to discuss the points where it shines at the architectural level. And we cannot talk about GraphQL without making a small comparison with REST, because I've seen that there are a lot of discussion, like it would be debate between them and not a matter of just using a specific tool for a specific job. So with GraphQL, we have a specific request, specific response. In REST, we know that we are requesting by endpoints and see exactly what we get and then what we can use from what we are getting from the server. We no longer have so many endpoints. If with REST we have endpoints for each operation, with GraphQL we only need one endpoint. And the result is specific and specific to our specific request, as we were saying before. Related to the complex data requests, yes, in REST, when it comes to complex payloads, we might require to make multiple calls. In GraphQL, we just call once, and this is it. Of course, again, it's depending on what is the shape of the data. When it comes to error code processing, REST is giving us HTTP error codes. GraphQL returns 200 and just wraps the error information. And in GraphQL, we don't have anymore the versioning issue that we had with REST. It's just an implementation through the schema extension. So we are extending it and not creating a new version of it. So just visually seeing how this works is not the same call. It's just making a statement regarding how it looks when we are using REST versus when we are using GraphQL. So it looks a bit different, and as we can see, we are creating only a call. So one of the biggest drawbacks of REST APIs is that they don't have a schema, at least in my opinion, they don't have a schema describing the data structures that we have access to. So if it's to think about, or I'm just taking I think, case that we all encountered. You are in a refinement session, you just receive an endpoint for certain functionalities. Well, looking at that endpoint does not really give you any information. So if you have something like something participants, you just can guess that, okay, maybe it's, I will get some details about the participants, but it's not really clear about it. Well, in GraphQL, this schema that we were talking about is serving as a contract. So actually this thing is called introspection, and I have the possibility, without needing to worry about how the API is implemented, just to see exactly what operation do I have available without having any knowledge in the server side. So we were saying about the places where GraphQL really shines. The client gets more freedom respecting the data it gets. Well, we already talked about this. I'm not going to insist very much, although it's a very important point. The possibility to serve several clients, because this actually suits very well the situation that we are talking today. GraphQL doesn't need dedicated endpoints. We have everything defined as a graph. And through the queries, we can get the specific data that we need. So while I have the system exposed with all the capabilities, I'm just fine. I just have to see exactly what are the operations that are available, and I'll just get the data that I need. When it comes to discussing how it's making it easier for different clients to coexist and evolve, we have very good examples of Netflix and SoundCloud, the situation that they had and how actually they've been able to grow. So how about I have a complex system with a lot of REST services in place, services used by several clients, mobile and web, and I don't have the time or the resources to change them all. And at the same time, I really want to optimize the data that I'm retrieving. So I want something without making a lot of effort. Can I get the best of both worlds? Well, one approach, it's actually this one, where the client basically dictates the way the response is looking like. So it queries the server as precisely as possible, or as precisely as I need it. And then the server resolves the queries and returns the requested data to the client. So this is everything happening in that blue area in between. This is an option that we can use in order to actually put them together in order to balance a bit this interaction that we have and the issues that we've discussed before. Of course, that there is a saying that in everything good there is something bad, and in every bad there is something good. But also in here, we have to be very careful about the way that we fragment our data. Because let's say that I have the services that are talking with my middle server. But if I'm doing some very complex queries that are requesting data from different services, I might not resolve very much. I have to be very careful about how I integrate and definitely fragment my data and my queries and the operations overall in order to avoid making many calls to the server, yeah, if I'm in this last situation that we discussed. Because we just have to think that if I'm doing this once when the application is small, maybe it's not that significant, but when you're doing this in very complex data types and in services that are already very slow, we might have some issues. So we have to be very careful about how we nest our data and how we are actually serving it. The other one comes in terms of something that I've read on the blog of React team. And they were saying something like, when they are designing APIs, they don't start with the abstraction itself. They are more like thinking about the desired user experience and work backwards to the abstraction. Well, in this case, it might be a bit tricky, especially if you want to serve different clients. So the BFF actually allows you, allows your team, your backend team, to actually build the API that makes sense. What does this mean? It should still absorb the complexity of a good API, of course, but they do not need to build it with one specific UI in mind. So they just try to, actually you have to try to detach yourself from the UI and try to create as try to see actually the relationships between entities and try to make them make the design as smooth as possible. And because I've been thinking about this for a long time and all this situation and all the scenarios and trying to compare them in order to find the best solution, I came to some conclusion, and that is that the front-end developers need to build their own backends. There is no really in between. And yeah, it's very important to actually quit this mindset that the backend should do its job and the front-end should do its job. You have to think of the backend more as an extension of the front-end and try to work together. Although you don't have to master, we are not saying that the front-end developers now, they have to also know a lot of server-side things, but even though you're not mastering the stack, does that mean that we don't need to have an overview? We need to just ignore everything about the application? I came to the conclusion that it's very important to actually create an overview, understand how the two are interacting. And this is the only way to actually help us in creating strong applications with, let's say, with easy ways to actually maintain it and to be as user-oriented as possible. Even if in the long run, we also have to be careful about the business requirements. But again, if we have the overview and actually try to take ownership on this side, it would be awesome. Very important is that in the moment that we are deciding, if we are deciding to use a BFF approach, the team that it's actually creating that middle server should be the front-end team. Because who is in the front area to actually understand what the needs of the users are and just see exactly how those entities should interact with not the front-end developers. If we are just trying to bring a different team to actually do that job for us, we are just going to end up in the same place we started from. So basically the BFF and the GraphQL, or this combination, pushes front-end developers to take a lot of ownership, as we actually somehow started from. I really hope that my words today marked a point of interest, and that you got so curious that maybe you try to dig a bit more on the matter, and maybe pay more attention to the subject in the future. Whatsoever, I want to leave you with this thought, that there is no silver bullet or golden hammer to solve our problems. What works well in one project can be pretty damaging in another if used mechanically or without prior research. And I really liked this saying, that there is some inherent complexity in software development and no magic tool will remove it. And I really think this is true. And I always, when I take a decision, I always think about this, because it's important to have a perspective also, not only on the good sides of the decision that you're taking, but also on the bad side and what it might go wrong. So choose wisely, research, and go with the choice that gives you the smallest cost and the biggest win. Can you combine both REST and GraphQL in the same API? And if yes, would this be okay, or it would be considered a best practice? What you can use from GraphQL, it's actually, you can combine it with something that is called Apollo for REST. Actually, Apollo, it's a client that it's used in GraphQL. There is also the Apollo server, so it's actually helping you to use GraphQL in your applications, and also doing the operation for frontend. So through that library from Apollo, you can actually, you have a way to consume data from your REST APIs through Apollo. So you are creating some queries, and they have the API very, very well structured in order to actually have the answer as specific as possible, and not to bringing all the payload if your API is actually giving a very bloated payload normally.
So without that library, you can't combine, you can't have some REST endpoints and one endpoint for GraphQL.
You can do this. Let's say you have 3 services that are REST, everything gets fine, and you have one that is GraphQL, because let's say you are trying to migrate. Through this approach with the BFF, yeah, middle layer, you can combine them all, because in the end, it's all about the data that is going to be displayed in the front end. So yeah, actually, it is a good practice, at least for from what I've seen. It's a good practice for the teams that try to go from a monolith to microservices.
Oh, yeah, that was my question. And the reason I asked this is because I was thinking that if you use GraphQL, can you limit access to some users, to some resources? Because with GraphQL, you basically give them access to everything, right? So in my head, I was thinking that you could use REST to use roles and stuff like that to limit access to resources, and the ones who have access to GraphQL could access everything. But can you do that with GraphQL only? Like administrators can access that data, but
actually you can limit the users that are accessing a certain. So you can create some sort of authentication also in GraphQL in the server part, in order to actually be able to restrict some access from certain areas.
Oh, so that's possible with GraphQL.
Yeah.
Yeah, nice.
Yeah. Can you tell us some of the challenges we might encounter in terms of versioning when using one or the other solution? But when it comes to using BFF, I guess it's the BFF with GraphQL. If we are using the GraphQL, actually, if we are using BFF only or BFF and GraphQL, the same issue persists if you are consuming some services that still need versioning. So the issues that you've been having before are still there, but the only difference is that you are not handling that versioning at the client level, you are doing it in that middle layer. but the challenges are the same as in a normal application.